Well, today we're going to talk about one of the great instruments of science, the Voyager spacecraft.
This is the one that's traveled farthest from home, Voyager 1. She bears a message to 1 billion years from now. Although Voyager 1 has been exploring the cosmos for over 45 years, it hasn't seen it all. It keeps uncovering something new every day, and its recent discovery, validated by Neil deGrasse Tyson, remains a mystery to the scientific world. The spacecraft just detected the existence of 775 celestial objects while exploring interstellar space. Are these mysterious celestial objects real, or are they the result of inaccurate data transmission from Voyager 1 to NASA? Could they be the handiwork of extraterrestrials? Join us in this video as we explore how Voyager 1 recently detected 775 unknown objects passing by in space. Neil deGrasse Tyson is a familiar face in the scientific community, which he officially joined when he gained admission to study physics at Harvard University. An astrophysicist, author, and science communicator, Tyson has been an advocate for expanding the operations of NASA. He believes that NASA is underfunded to effectively execute the work that needs to be done. Besides speaking up for more funding for NASA, Neil deGrasse Tyson has never shied away from conversations on what transpired in the universe long before we came around. He also believes that there is still a whole lot we don't know about the universe we live in, and it's only fair that we explore them. This explains why Tyson's interest was piqued recently when Voyager 1 detected 775 unknown objects passing by in space. Mother Earth is a remarkable planet with several mind-blowing features, but compared to the rest of the universe, it is just a mere speck. Philosophers have known this for several centuries, but they didn't have a chance to prove this statement until NASA scientists came along with a spectacular invention in the 70s. However, this invention might not have come into existence if not for the alignment of the stars, which, in the real sense, are the four largest planets of our solar system. The alignment of the four planets had largely been unnoticed until it got the attention of Gary Flandreau, a Ph.D., student at the California Institute of Technology. Flandreau, who was working part-time at NASA's Jet Propulsion Laboratory, charted the orbital paths for the giant planets Jupiter, Saturn, Uranus, and Neptune. When doing this, he stumbled upon something amazing. He found out that in the late 1970s and early 1980s, all four planets would be strung like pearls on a celestial necklace in a long arc with the Earth. This discovery excited Flandreau's superiors at NASA because he had been tasked with finding out the most efficient way to send a space probe to Jupiter and the other giant planets. Back to this rare event that had unfolded in the eyes of NASA scientists, it meant that a space vehicle could get a speed boost from the gravitational pull of each giant planet passed. It would be as if it was being tugged by an invisible cord that snapped at the last second, flinging the probe on its way. From Flandreau's calculations, it was estimated that the repeated gravity assists from the planets would cut the flight time between Earth and Neptune from 30 years to 12 years. However, there was one setback to the excitement surrounding this discovery. The alignment occurred once every 176 years. Thus, to reach the planets while the event lasted, a spacecraft would have to be launched in the mid-1970s. This information was passed up the NASA hierarchy, and the space agency decided to seize this once-in-a-lifetime opportunity by developing two spacecraft. These twin spacecraft are known as Voyager 1 and Voyager 2. The spacecraft are twins in every sense because they have identical details. However, they were launched within 15 days of each other in the summer of 1977. Precisely, Voyager 1 was launched into space on September 5th, 1977. The space probe is a part of the Voyager space program, tasked with the mission of exploring the solar system and interstellar space for our benefit. Voyager 1 has been in operation for almost 5 decades and has been communicating with the scientific community through NASA's Deep Space Network. It receives routine commands and transmits the data back to Earth. We are able to monitor the real-time distance and velocity data thanks to NASA and its Jet Propulsion Laboratory. As of August 2023, the space probe was situated 24 billion km away from Earth, making it the most distant man-made object from Earth. The Jet Propulsion Laboratory executed the design and construction of Voyager 1. The probe left our planet from Launch Complex 41 at the Cape Canaveral Air Force Station aboard a Titan IIIe launch vehicle. Voyager 1 made its way into space 2 weeks after its twin, Voyager 2, had been launched. NASA launched the probe with the objective of conducting outer planetary heliosphere and interstellar medium exploration. NASA had been very keen on studying what happened or existed between the stars, and the Voyager mission was going to make this dream a reality. Early on in its development, NASA scientists had decided that the spacecraft had to make a flyby over Jupiter, Saturn, and the latter's largest moon, Titan. Although Voyager 1 had been launched later than its twin, it still arrived at Jupiter before Voyager 2. It explored the two gas giants, studying their weather, magnetic fields, and rings. Thanks to Voyager 1, we were able to get detailed images of the moons of Jupiter and Saturn. As mentioned earlier, the Voyager craft mission didn't stop at studying Jupiter and Saturn. The space probe went further to locate and study regions and boundaries of the outer heliosphere. It also extended its operation to include the exploration of the interstellar medium. The spacecraft crossed the heliopause and entered interstellar space on August 25, 2012. Voyager 1 made history by being the first spacecraft to achieve this feat. As the universe would have it, we got confirmation that the Voyager was indeed in interstellar space 2 years later, in 2014. The spacecraft began experiencing a third tsunami wave of coronal mass ejections from the Sun, and this continued until December 15th of that year. It was Voyager 1 that gave us the first family portrait of the solar system as seen from outside it. It also provided a famous image of the Earth that was soon nicknamed Pale Blue Dot. After exiting the heliosphere, Voyager 1 headed straight for interstellar space. It was time to explore in between the stars. Nevertheless, the instruments of the probe kept studying the solar system. Voyager's mission was expected to end many years ago, but NASA's engineering team seems to have performed their magic on the spacecraft. They have succeeded in extending the spacecraft's mission to 2025. By this period, it is expected that it would no longer have enough electric power to operate its scientific instruments. The team achieved this feat by testing the space probe's trajectory correction maneuver (TCM) thrusters in late 2017. This was the first time these thrusters had been fired since 1980. The decision to fire the thrusters succeeded in extending the mission's lifespan by 2 to 3 years. One look at the gains achieved by Voyager 1 in the past 4 decades, and it would be hard to believe that the craft's launch almost failed in the summer of 1977. This was because a part of the launch vehicle had shut down prematurely, causing 1,200 pounds of propellant to become unburned. Nevertheless, Voyager 1 is currently traveling at about 523 million km per year, which is about 1 light year per 18,000 years. Speaking of traveling, Voyager 1's high-speed journey would have been a waste of time if it wasn't equipped with the right instruments. The spacecraft has 16 hydrazine thrusters, 3 axis stabilization gyroscopes, and referencing instruments that keep the craft's radial antenna pointed toward Earth. These instruments work together and are a part of the attitude and articulation control subsystem AXEs. The Voyager craft has 8 backup thrusters and is equipped with an additional 11 scientific instruments for studying celestial objects as it explores the cosmos. The scientific instruments include an imaging science system, radio science system, infrared interferometer spectrometer, ultraviolet spectrometer, triaxial fluxgate magnetometer, and plasma spectrometer. The other 5 are low-energy charged particle instrument, cosmic ray system, planetary radio astronomy, photopolarimeter, and plasma wave subsystem. Some of these instruments are active, while the rest are either disabled or defective. NASA engineers designed the radio communication system of the Voyager to be used up to and beyond the limits of the solar system. The communication system consists of a 3.7-meter diameter high-gain antenna to send and receive radio waves via the 3 deep space network stations on Earth. When Voyager 1 is unable to communicate directly with the Earth, it uses its digital tape recorder, DTR. The DTR can record about 67 megabytes of data for transmission at a later time. As of 2023, signals from the Voyager take over 22 hours to reach planet Earth. Additionally, the Voyager was designed with highly sophisticated cameras for capturing images of planets, their moons, and other celestial bodies from a distance. However, the operation of the cameras for visible light is not automatic. Instead, it is controlled by an imaging parameter table contained in one of the onboard digital computers. NASA has since moved on from this design, as succeeding space probes from the 1990s have been equipped with completely autonomous cameras. Voyager 1 has a computer command system, CCS, that controls its cameras. The CCS is equipped with fixed computer programs such as command decoding, fault detection routines, and appointing routines, and spacecraft sequencing routines. The CCS is an upgrade of the one used in the 1970s Viking orbiters. It's been nearly 5 decades since Voyager 1 and its twin, Voyager 2, were launched into space to study the cosmos and bring exciting discoveries to our knowledge. The spacecraft's instruments have been operating consistently over the years by transmitting data back to our planet. One would have expected that this spacecraft, which is located over 14.1 billion miles away from Earth, would have begun to fail. But this is far from the case, as Voyager's computer systems continue to work effectively, capturing and transmitting data back to NASA scientists. We have NASA engineers to thank for the longevity of Voyager 1 in achieving its interstellar mission goals. NASA scientists have been able to sustain the operative capabilities of the Voyager craft through power management and the use of redundant computer subsystems. They have conserved the power of the spacecraft by switching off non-essential systems, ensuring the longevity of the spacecraft. However, it's not just about maintaining the longevity of the equipment, but also ensure that it can successfully process scientific data. If not, they risk losing the prize spacecraft to changing conditions. Over the years, the Voyager spacecraft has been self-powered using radioisotope thermoelectric generators, RTGs. These RTGs, also known as radioisotope power systems, are a type of nuclear battery that uses a thermocouple to convert heat from decaying plutonium into electricity. The generators have no moving parts, which means there's no risk of parts wearing out or malfunctioning. Additionally, they don't need solar energy, making them suitable for remote and harsh environments, such as the outer reaches of the solar system. Despite the advantageous features of the radioisotope power system, the continual decay process means that the generators produce less power each year for Voyager 1's use. Although the dwindling power supply hasn't affected the spacecraft's mission output, NASA engineers took the preemptive step of compensating for the power loss by switching off heaters and other non-essential systems that don't affect the spacecraft's flying capabilities. However, it seems like not only non-essential systems will have to be turned off to keep the craft flying and maintain effective data transmission. Scientists are considering switching off one instrument on the spacecraft, although the decision has not been made yet.